Hello everyone. The objective of this video is we will demonstrate what is the runtime behavior of the RTOS when you send an item to a high priority task that was blocked on waiting for items in a queue. So here we have a skeleton of producers producing items, consumers consuming items. But unlike the previous queue videos you may have watched, what I have changed is on the consumer side, the consumer is high priority. So before I run this program, and before you look at my screen here, we can determine that the consumer task or thread will run first. So the consumer is going to run first, print a line, and it's going to say, hey, I'm about to invoke the XQ receive. And the consumer is going to run first because he is a high priority thread or task. Then it's going to get blocked on a queue. And after receiving an item from the queue, it's going to then say, hey, here's a item that I received. On the producer side, we have similar code. We have printfs surrounding an XQ API. You have a producer saying, I'm about to send an item, calls XQ send, and then the producer says an item was sent. So what we will see is very interesting behavior. So let me compile this program and run it. This one we determined, right? The consumer runs first. He's about to invoke the XQ receive API. Then the next line of code on line number 37, it gets blocked because there's nothing in the queue yet. When we get blocked, this gives a chance for the producer to run. So there is a context switch number 1 happening here because this switches over to producer because this task or thread is going to get blocked. Inside of XQ receive API, FreeRTOS is going to do a context switch over to the producer. And this is cooperative scheduling kicking in. Now, producer will do printf of, hey, I'm about to send an item into the queue. So that matches up here. And then very interesting behavior happens. Notice that when we send an item in the queue on line number 23, we don't even go to the next line of code, which says that, oh, this is a typo, which says that producer has sent an item. What happens instead is that when producer says, I'm about to send an item, let's recompile and run it actually. So when the producer says, I'm about to send an item, he doesn't even get to the next line of code that says item was sent because producer is lower priority task, right? You just sent an item onto a queue, but a higher priority task or thread was waiting on it. So inside of XQ send, there is a context switch number 2. And this switches back to consumer because consumer was a high priority task. And this is the real-time behavior of an RTOS, right? Consumer is a high priority task, was waiting on an item. And as soon as the item showed up, inside of line number 23, inside of the code for XQ send, it switches back and wakes up from the sleep or block behavior. And then the consumer says, I received an item. So on line number 38, consumer says, I received an item. Remember, consumer is high priority, so he's going to keep running, loops back around and says, okay, consumer is about to receive an item from the queue again. And at this time, line number 37, there is another context switch. So when the second time we loop around, there is context switch number 3 because there is nothing in the queue anymore. We just consumed an item that appeared, and because there's nothing in the queue anymore, we get blocked again. So this one, context switch number 3, goes back to line number 23. And the next line of code is going to be item was sent. So in this video, what we're essentially demonstrating is that as soon as you send an item into the queue, If another thread was blocked on it and that thread is higher priority, you're going to have cooperative context switches inside of the queue API, where inside the XQ send, producer is going to go to sleep. He's going to get blocked. And when producer gets blocked, the context switches back over to consumer, which was waiting on an item because he's higher priority. And when that guy consumes the item and gets blocked again, then line number 23 resumes. So this is, again, in summary, the real-time aspects of an RTOS, where the context switches immediately to somebody who is higher priority, and as soon as an event unblocks that person or thread, that thread will start to run immediately. Thank you.